To build a conceptual understanding of how images work, let's take a look at a simple example. Here I've opened up the street bitmap sample file. As you're probably already aware, digital images are made of pixels, or tiny building blocks of color. This becomes evident when you zoom into an image. Each time I zoom, the image gets grainier and grainier. At a certain point, a figure ground shift occurs in your perception, where you start to perceive the pixels that make up the image. Here I can see the individual pixels are either black or white. This is the simplest case. You're also probably aware that computers are binary, meaning they work with ones and zeros. The fundamental unit of information in a computer is called a bit, and a bit can either be a 1 or a 0. And this visual information maps over to the memory in a computer directly in a bitmap. This means that white is 1 and black is 0. So this is the most efficiently stored kind of image you can make in a computer, called a bitmap. Each pixel is one unit of information, or one bit. Taken together, the figure ground shift occurs in your mind, and you perceive the image as a whole. Let's look at another example. This is the street Grayscale sample file, and it contains far more information than the previous image did. We'd call this a black and white photo, but in reality it's a grayscale image. You can go up to the image menu and see that we're in grayscale mode. This means that each pixel can have a whole range of grays. It doesn't have to be black or white, but it can be somewhere in between. If I zoom in closer, each time the image gets a little bit grainier, and if we go in close enough, that figure ground shift kind of occurs, and we just see this shape of pixels here, which is the lamppost. I'll go to the eyedropper tool here, and I'll take a point sample, and I'll click on a pixel. That puts the color of the pixel into my foreground color swatch here. You can see that this is right here, between white and black. That can be represented numerically over here as 155. Start going around with your eyedropper and you can get different values. This is a darker shade of gray, and it comes across as 66. A lighter shade of gray is a higher number. In fact, these pixels can vary between 255 for pure white and 0 for pure black. That gives us 256 different possibilities. Now that's an important number. Let's take a look at this other image I've prepared called Powers of 2. So right here, if you have only two possibilities, black or white, you have what's called a bitmap. If you have 256 different possibilities for each pixel, then you have a grayscale image. It's said to have a bit depth of 8, also known as an 8-bit image, because the number of possibilities is equal to 2 to the 8th power. Why 2? It's because computers work on this binary arithmetic, 1 or 0.